3D trig from the absolute basics. Alright, so what will you need to know? You need to know everything that you've done in 2-unit trigonometry so far. So SOHCAHTOA, Pythagoras' theorem, sine rule and the inverse of the sine rule, and the cosine rule. You won't use all 4 of these in every single question, but there are a variety of questions that they can ask, and in general you'll use at least 2 of these in every question. Sometimes you'll have to use 3 of them. So maybe even 4, but you will be using these on a regular basis in 3D trigonometry, so you really need to know them. And a key skill in 3D trigonometry is to know when to apply which rule. You need to know, okay, this is a Pythagoras' theorem question. No, hang on a second, I can't apply Pythagoras' theorem here. This is not a right angle triangle. I have to use the cosine rule. So you need to know when to apply which of those rules, right? And the basic idea in 3D trigonometry is you'll be given a question and you have to interpret the wording of that question to make a 3D diagram. Now, don't think that you're wasting time. Oftentimes, if you don't make the 3D diagram, you'll just lose that time in making silly mistakes or, fixing up small mistakes here and there. Just do it. It takes 30 seconds and it doesn't take long at all, and it's really worth it. And once you've interpreted the question and made a 3D diagram, I strongly recommend that you convert the 3D diagram into a series of 2D triangles, right? And again, it looks like a waste of time. It's not. It's worth it. Just do it. And the idea is to convert this new type of question into a 2D triangle question, which we know how to solve. I mean, we've practiced in 2-unit maths. We've practiced sine rule, cosine rule, trigonometry, SOHCAHTOA. We know how to do those. We can do those really easily. So convert the 3D diagram into a bunch of 2D triangles, and the question becomes a piece of cake. Really, it becomes really easy. And because these 2D triangles will have simple basic trigonometry relationships such as SOHCAHTOA, Pythagoras' theorem, sine rule, cosine rule, whatever. Now, I will solve the question above where the height of a building is measured to be 1500 meters, so on and so forth, and I want you to solve the question at the bottom at the same time. Maths is never learnt passively. You will not learn maths by watching a video or watching a teacher how to solve it or copying down a bunch of worked examples. No, you have to actually do it yourself. And so the question I'm going to do above, it's almost exactly the same as the question below, so you have to do the question below. Pause the video, read the question, compare the 2 questions. You'll see that they're very, very similar, and just please do yourself a favor and work with me. Post up once you've got your answer, post it up on Slack. So the question I'll solve is, there's the height of a building, a tower, a building, 1500 meters tall. Person A and person B are due south and east of the building respectively. The angles of elevation from person A and person B to the top of the building are measured to be 23 degrees and 38 degrees respectively. How far is A from B? As always, like I said earlier, step 1, draw a 3D model. And I've got a model over there. And you might be wondering, how did I come up with that? Well, let's have a look. So this is the diagram I've drawn up. There's a tower, there's a building. Person A is due south, as you can see, due south, and person B is due east. And that's a 3D model. It is 1500 meters tall, as you can see, 1500 meters tall. And what do we need to find? How far is person A from person B? And as you can see, it's a 3D trigonometry. I've drawn up the 3D diagram, right? Now you might be wondering, oh yeah, and the angles of elevation and the angle of elevation from A and B is 23 degrees and 38 degrees respectively. So make sure you note that in. Now you might be thinking, well, so we won't have a 3D modeling software on hand while we're doing an exam. So how do we do it by hand? Let's do it by hand. First thing you do, any 3D trigonometry question, first thing you do, draw an east-west line. And then you're marking the north-south line. This is how you start off in any 3D trig question. Now, make sure you draw a slanted north-south line because you want to be able to differentiate between up and down and north and south, right? So let's read the question and you will get a feel for it. The height of a building is measured to be 1500 meters. Well, let's draw a tower. Let's draw a building 1500 meters tall, right? And we've marked on the top of the building T for top, G for ground. person A and person B are due south and east of the building respectively. So let's mark in person A and person B. Now, it's also worth noting down that due south and due east means that the angle at the middle is going to be 90 degrees. AGB is 90 degrees because south and east are 90-degree angles apart, right? This is important. This sort of information is very important to note down. So, next thing, we're going to keep reading the question, right? The angles of elevation from person A and person B to the top of the building are measured to be 23 degrees and 38 degrees respectively. Let's draw that in. Angle of elevation from A to T is 23 degrees, and from B to T is 38 degrees. And how far is A from B? Well, we draw A to B, and we'll mark it in as D question mark. That's what we have to find. Now, we have step 2 was to convert a 3D diagram into separate 2D triangles, a bunch of 2D triangles. And the way we will do that is we'll go over to our 3D model and I will just illustrate. If you can visualize, that's all well and good. But if you can't visualize it, well, first thing we're going to do is we're going to look at that yellow thingamajig, that triangle. If you go like this, if you go like this, right? Imagine in a real exam you'll be doing this, in your head, just doing it, just imagining it. But look, you have A, T, G. You have a triangle, A, T, G. A, T, G. Let's mark it in 23 degrees at angle of elevation, 1500 meters height. Similarly, we go and we look at the blue triangle. Well, B, T, G. The height of 1500, BTG. And we draw that in as well, remembering the angle of elevation. And the last thing we're going to look at is this triangle. We have to find D. I'll put it like this, so it's a bit easy to visualize the fact that it is a 90-degree angle, and that is D. Right? ABG. ABG. Now, one thing that's worth noting is that BG is shared. BG is shared between the purple triangle and the blue triangle. And note the BG in the rightmost triangle and BG at the bottom in the middle triangle. This is really, really important. We're going to use this in a second. And similarly, if you do like this, right, you can see that, just in a second, you can see that AG is also shared between the purple and the yellow triangle. AG is common. So note AG on the rightmost triangle and the bottom side on the leftmost triangle, AG. They are shared. They'll be equal. So if AG is 10, then it's going to be 10 on both of those triangles. Okay, whatever. Let's just keep that in mind. Now we need to find AB. We're going to call it D. For the sake of simplicity, we'll call it D. And we're going to call BG B and AG A. And it's worth noting that all 3 triangles are right-angled triangles. That's really important because it tells us that we can use SOHCAHTOA and Pythagoras' rule. And those are the 2 tools we're going to use to solve this question. So let's get started. I've noted down all the common sides, A, B, D, and as you can see, I've noted the common sides. Pro tip: if you have to find a value in a right-angled triangle, you have to be thinking, oh, I have to use a Pythagoras theorem, or maybe the cosine rule. Oh, sorry, the SOHCAHTOA rule. And on the other hand, if you have to find a value in a non-right-angled triangle, then you only have 2 options, either the sine rule or the cosine rule. So let's get started. We need to find D. We don't know anything about D in the rightmost triangle. However, we can find out B and A using SOHCAHTOA in the middle and the left triangle. And once we found B in the middle triangle and A in the leftmost triangle, we can substitute the value of A and B into the rightmost triangle, where we can use a Pythagoras' rule to find D. And this is the essence of 3D trigonometry. You have one triangle where you have no information, and you have 2 other triangles where you do have information, and you have to use the information you've been given in those 2 triangles, move that information into the first triangle of which you know nothing about currently, and then you can solve it. That's just 3D trigonometry in a nutshell. This pattern repeats again and again and again. Alright, so let's get started. First triangle. We have to use SOHCAHTOA. As a right angle triangle, we can use SOHCAHTOA. Now 23 degrees is the angle we've been given, and the two sides are TG and AG. They are opposite and adjacent, so it can't be so, can't be ka, it has to be toa. Tan opposite over adjacent. Tan 23 is opposite over adjacent, which is 1500 over A. We're going to make A the subject because that's what we really want to know. A is that, right? Now, one really important tip that I'm giving you now is to use your calculator's storage function. So let's say, for example, what I'm going to do is 1500 divided by, let's just clear the calculator's memory first. So we're going to clear 3 equals AC. Now the calculator's memory is cleared. So 1500 divided by tan 23, and I'm going to store, so note that carefully, shift store this RCL button just above 7, and I'm going to put it into A. There's a just above the recall button, just above the store button, there's a red A on top. I'm going to store it into A. Now the calculator will remember the exact value for me, and it saves a lot of algebra towards the end. And you'll see in a second why it can get so complicated so very fast. And there, let's get the second triangle. Similar process. Tan opposite over adjacent. Tan 1500 over B, and make B the subject. And again, we are going to store it. So let's just store it over here as well. 1500 divided by tan of 38, and I'm going to store that into B. Done. Easy. Now, we know A and we know B. We're going to use Pythagoras' theorem to find D. D squared is equal to substituting the values of A and B. And as you can see, if you did that on a calculator, it can get kind of annoying to put in. And it's possible to make a silly mistake here and there. So what we're going to do is we're going to use the calculator's A and B function, which we've just been using. So we have square root, obviously. So let's go ahead. Square root of alpha A squared plus alpha B squared, and equal sign, and we have our answer. And that's it. That's 3D trigonometry. It's actually not that hard. The hardest thing about it is visualizing the question and converting it into a 3D diagram, and then using that 3D diagram to make a bunch of triangles. Once you have those 2D triangles, it's just 2-unit math stuff. Not even 2-unit maths. I dare say it's year 9, year 10 stuff, because it's just SOHCAHTOA and Pythagoras. You have to use sine rule, cosine rule, but yeah, that's not really hard. It's just number crunching. So it's pretty easy. It's just a lot of practice. Just practice this, and you'll see that the pattern repeats. This question that we've just solved is fairly typical. You'll actually see this in past paper questions, this sort of question. So just good luck, and make sure don't forget to put up your answer on Slack.